Why have CPU manufacturers stopped increasing the clock speeds of their processors? I have read that manufacturers stopped concentrating on higher clock speeds and are now working on other things to improve performance. With an old desktop machine with Intel Xeon processor E3110 with clock speed of 3.0 GHz, and a new server with AMD Opteron TM processor 6272 with clock speed of 2.1 GHz. When performed a simple encryption comparison using single-threaded, the desktop performed far better than the server. So even with latest optimization, why does the processor with the better clock speed perform better?
Your test case, AES-256 encryption, is very sensitive to processor-specific optimizations. There are various CPUs that have special instructions intended to speed up encryption/decryption operations. Not only may these special instructions be only present on your desktop, it might be that the AMD CPU has different special instructions. Also, OpenCell might support these special instructions only for the Intel CPU. Did you check whether that was the case? To find out which system is faster, try using a proper benchmark suite, or better, just use your typical workload.
The reason manufacturers have stopped concentrating on increasing clock speed is because we can no longer cool the processors fast enough for this to be viable. The higher the clock speed, the more heat is generated, and we've now hit a stage where it is no longer efficient to increase processor speed due to the amount of energy that goes into cooling it. Other answer goes into detail on how higher clock speed doesn't mean better performance in all areas.
Why do you think the manufacturers are actually lowering the clock speed by only comparing two processors? The 6272 has a turbo speed of 3 GHz. The lower base speed is just for lowering average wattage and keeping an acceptable TDP for a workload when all cores are stressed. AMD's next high-performance chip for desktop, the FX 9590, will hit 5 GHz. Also, clock speed isn't the same as performance per clock cycle. You can have a 3.8 GHz P4 versus one 3.2 GHz core from AI7-3930K, but that doesn't mean the P4 core is faster. Everything said here about power consumption is also perfectly valid and true for a 16-core design, where you naturally got to be more concerned about TDP issues. Also, your benchmark method just testing OpenCell is a bit too simple to give real-world numbers. Maybe you should try any crypto benchmark suite.
There is a lot more to processing speed than the clock rate. Different CPUs can do different amounts in the same number of clock cycles, due to different variants on pipeline arrangement and having multiple component units, adders and so forth, in each core. While in your test it is not the case, you often find a slower chip can do more than a fast one, measured by clock rate only, due to being able to do more per tick. The test you performed may be very sensitive to differences in CPU architecture. It could be optimized for a specific architecture. You might find it performs differently not just between Intel chips and AMD ones, but between Intel or AMD chips of different families. It is likely using a single thread too, so is not taking advantage of the CPU's multiple cores. There is a move to lower clock rates for power and heat management reasons. Ramping up the clock rate does not have a linear effect on power use and heat output. Because of the above nonlinear relationship, it is far more efficient for today's requirements to have multiple processing units than it is to push the speed of one unit ever higher. This also allows for clever tricks to conserve power, like turning off individual cores when not in use and revving them back up as demand increases again. Of course, multiple cores doesn't help a single-threaded algorithm, of course, though it would if you ran two or more instances of it at the same time.